Outside of just triple integrals over boxes, we're also going to see triple integrals over generalized solids. Now, for a given triple integral, there are three different ways that we can integrate first. So we're going to classify these as one of three different types. So suppose that we have the triple integral over the solid, we'll refer to it as E, of f of xyz dv. So there are three possibilities for the kinds of things that we could potentially see. First one being that z is bounded between two functions of x and y. We'll refer to these as u1 of x and y and u2 of x and y. Then we'll say that all of the ordered pairs x and y can be found within some domain D. Now, if this is the case, that means that we can turn our triple integral of f of xyz dv into a double integral over the region D and a single integral from u1 of xy to u2 of xy of f of xyz dz. Then the double integral will be in terms of dA. And this is where dA can either be equal to dy dx, or it can be equal to dx dy, depending on how you want to classify your region D. Second possibility is that we could bound y in between two functions. We'll call it u1 of x and z and u2 of x and z. And this is where all ordered pairs xz can be found within some domain D. In this case, we're setting it up so that we would be integrating with respect to y first. So the triple integral over the solid E of f of xyz dv is going to be equal to the double integral over your region D and a single iterated integral from u1 of x and z to u2 of x and z of f of xyz dy. Then evaluate the resulting double integral. And this is where dA can either be equal to dx dz, or it can be equal to dz dx. Final possibility for our triple integral is that x could be bounded between two functions of y and z. Once again, we'll refer to them as u1 and u2 of y and z. And this is where you'll have a bunch of ordered pairs yz that are contained within some domain D. Now, in the event that this is what you have, this means that the triple integral over the region E of f of xyz dv is going to be equal to the double integral over the region D and the iterated integral from u1 of y and z up to u2 of y and z of f of xyz dx. Then after that, you can go for dA. And this time dA will either be equal to dy dz or dz dy, depending on what your region D looks like. And do keep in mind that when you're evaluating these double integrals, it is also possible that dA could be equal to r dr d theta if a conversion into polar coordinates would make any of these double integrals easier.